everyone, welcome to my channel Chemistry is Fun. Today we will deal with the chapter Solutions. This is for class 12, 2025-26 and part 2 of the chapter. Today we will see solubility. Now what is solubility? Solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent at a specified temperature. So how much maximum amount we can dissolve in a specified amount of solvent at a specified temperature, that will be known as solubility of that substance. Now let us see solubility of a solid in a liquid. A solute will dissolve in a solvent if the chemical interactions are similar in both the solute and the solvent. So when the chemical interactions are similar, then only a solute dissolves in a solvent. So this follows the principle like dissolves like dissolves like. When a solid solute is added to the solvent, some solute dissolves and the concentration of the solution increases. This we have seen in a very general example. If you take sugar and water, when sugar starts dissolving in water, the concentration of the sugar solution slowly increases. So you can say that when a solid solute is added to the solvent, some solute will dissolve and the concentration of the solution increases. This process is known as dissolution. This is known as dissolution. At the same time, one more process takes place when the solute particles in the solution, they also collide with other solute particles and get separated out of the solution. The solute particles collide with other solute particles and get separated out of the solution. This process is known as crystallization. So both the processes take place together. This is also taking place, other one also. A stage comes when the two processes occur at the same rate. The two processes occur at the same rate. Then we say that a state of dynamic equilibrium is reached. That is the solute plus solvent, and this is the equilibrium with the solution. At this stage, the concentration of the solute in solution will remain constant. The concentration of solute in solution will remain constant under the given conditions, that is temperature and pressure. So the condition should be maintained of temperature and pressure, and here these two processes occur at the same rate. So a solution in which no more solute can be dissolved at the same temperature and pressure is called as saturated solution. So if we do not change the temperature or pressure, no more of the solute can be dissolved in that solution, then we call it a saturated solution. In unsaturated solution, more solute can be dissolved at the same temperature. If the solution is unsaturated, more solute can be dissolved at the same temperature. So we can say that in a saturated solution, it contains maximum amount of solute in the dissolved state in a given amount of solvent. And the concentration of solute in such a solution is called its solubility. So the solution in which the solute in the dissolved state is in dynamic equilibrium with the solute in undissolved state is called as a saturated solution, and it contains maximum amount of solute in the dissolved state in a given amount of solvent. The concentration of solute in such a solution is called solubility. Now we have to see effects of temperature and pressure. First of all, let us see effect of temperature. The solubility of a solid in a liquid is affected by temperature changes. And if there is dynamic equilibrium, it will follow Le Chatelier's principle. Let us see what it is. Le Chatelier's principle states that if the equilibrium of a system is disturbed by a change in one or more of the determining factors, such as temperature, pressure, or concentration, the system tends to adjust itself to a new equilibrium by counteracting as far as possible the effect of the change. So it means that in the system there is equilibrium, but this equilibrium is disturbed. Disturbed how? By changing either the temperature or the pressure or concentration. Then now this already equilibrium has been disturbed. Now what the system will do? The system will try to adjust itself and create a new equilibrium. How it will do that? It will counteract the effect of the change as much as possible for the system. Now in a nearly saturated solution, if the dissolution process is endothermic, the solubility should increase with rise in temperature, because the process is endothermic, and if we rise the temperature, the solubility will increase. That is, the system will tend to go towards solution side because it is endothermic and we are providing the heat, we are increasing the temperature. So in order to undo that change, the system will go towards solution side. So there will be the increase in solubility, that is, solubility should increase with rise in temperature. And if it is exothermic, the solubility should decrease, because if it is exothermic, then that is, the dissolution process is exothermic, and now we are increasing the temperature. Already it is exothermic. On that, if we increase the temperature, the solubility should decrease. That is, the system will tend to go towards solute plus solvent side, that is in the opposite side. Now let us see effect of pressure. Pressure does not have any significant effect on the solubility of solids in liquids. The reason being that solids and liquids are very less compressible. So pressure does not have any significant effect on solubility of solids in liquids. We have already discussed the topic that how we express the concentration of solutions. You can go through the last video which I have posted few days back. Based on that, we will do some numericals today. Let us see the first one. Calculate the molarity of a solution containing 5 grams of NaOH in 450 ml solution. 5 grams NaOH in 450 ml solution. First we need to calculate how many moles of NaOH are there. So to calculate number of moles of NaOH, we divide 5 gram by 40 grams per mole. 5 grams divided by 40 grams per mole, we get 0.125 moles. Now volume of the solution given is 450 ml, but we have to take volume in liters. Moles per liter we want. So to get in liters, we divide it by 1000 milliliter per liter. So this is the volume. Molarity is number of moles divided by volume. So it is 0.125 divided by 450 by 1000. So it becomes 0.125 into 1000 milliliter per liter by 450 ml. On calculating, we get 0.278 moles per liter. So this is the molarity. Next is calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. First we need to calculate molar mass of ethanoic acid, CH3COOH. CH3COOH is C2H4O2. There are 2 carbon atoms, 4 hydrogen atoms and 2 oxygen atoms, so it can be written as C2H4O2. To calculate the molar mass, carbon 12 into 2, for hydrogen 4 into 1, for oxygen 16 into 2. On calculation we get 60 grams per mole. So this is molar mass we got. Now we have to calculate number of moles, because amount of the substance given is 2.5 grams. So number of moles is 2.5 gram divided by molar mass, that is 60. We get 0.0417 moles. Mass of benzene in kilogram, they have given in grams, we have to convert it into kg. So mass of benzene in kg is 75 grams divided by 1000 gram per kg, that is 75 into 10 to the power minus 3 kg. Now molality of ethanoic acid will be, first we write number of moles and divided by mass of benzene. So it is 0.0417 moles divided by 75 into 10 to the power minus 3. So 10 to the power minus 3 goes to the numerator. It becomes 0.0417 moles into 1000 gram per kg divided by 75 grams. This value comes out to be 0.556 moles per kg. This is the molality of C2H4O2 which was asked in the question, that is of ethanoic acid. I hope students you all could understand the topic I discussed today, and also you could understand the numericals which I discussed today. Thanks for watching my video. Please subscribe to my channel and share the video. Thanks for watching. Thank you.